Hello my dear students, hearty welcome to all for the Samveda e-learning program. Today you are going to learn much more interesting concepts of the lesson light, reflection and refraction. Before going to learn the concepts of the today's session, let us recall what we have learned in the previous class. My dears, you have learned the following concepts in the previous session. That is, mainly you have learned about properties of light and reflection of light, how it is going to be reflect from the surface and the laws related to the reflection of light and the meaning of the terms used in the reflection of light. And also you have learned about reflection of light in plane mirror and spherical mirrors and their types and meaning of the terms associated with the spherical mirrors like center of curvature, radius of curvature, pole of the mirror, then principal axis, principal focus and focal length and all. Today you are going to learn about these important things and which are very interesting and also they are very important for the point of examination. The first concept you are going to learn is image formation by spherical mirrors and ray diagrams for the formation of image by a concave mirror and uses of concave mirror, image formation by a convex mirror and the uses of convex mirror. Finally, you are going to learn about mirror formula, meaning of magnification and formula used to calculate magnification. My dears, let us learn one by one. The first concept of today's class is representation of images formed by spherical mirrors using ray diagrams. So, when you are going to conduct experiment by using a concave mirror and a screen and we are going to place the object at different distances, we are going to get the image according to the position of the object which is placed in front of the mirror. My dears, before going to learn all these things, let us recall the meaning of principal focus, focal length, radius of curvature and all, because it is very important to learn the concepts based on image formation by a concave mirror. You know that based on the reflecting surface, we are going to classify the mirror into concave and convex. In case of concave mirror, the reflecting surface is curved inward and the ray which is passes parallel to the principal axis get reflected by the reflecting surface. After reflection, they are going to meet at a point which is on the principal axis. That point is called as principal focus. And you know that the meaning of pole of the mirror. If you are going to measure the distance between principal focus and the pole, we will get focal length, and you know that the meaning of radius of curvature. And also you learned the relationship between radius of curvature and the focal length. So, radius of curvature is always twice the focal length. This is in case of concave mirror. In case of convex mirror, you know that reflecting surface is bulged outward and the ray which is passes parallel with the principal axis reflect like this, and if you are going to draw the reflected line back, we will get the principal focus over here, that is capital F. Again, the distance between pole and the principal focus is called as focal length, and here you have center of curvature. So, if you understand these things, where the principal focus is located and where the center of curvature is located and what is the relationship between them, you can understand the ray diagrams easily. My dears, in a concave mirror, a ray of light parallel to the principal axis after reflection passes through the principal focus. Here you are seeing the animation, the ray which is parallel to the principal axis after reflection it is passes through the principal focus. In case of convex mirror, a ray of light parallel to the principal axis after reflection appears to diverge from the focus like this. It is going to be reflected like this, and you know that it seems to be appear from the principal focus in case of convex mirror. Now, the next thing is, in case of concave mirror, a ray of light passing through the focus after reflection goes parallel to the principal axis. If it is parallel to the principal axis, it passes through the focus. If it is passes through the focus, then it travels parallel with the principal axis. And you can notice the same thing in case of convex mirror also. Here, if the ray which is directed towards the principal focus after reflection moves parallel with the principal axis. In a concave mirror, a ray of light passing through the center of curvature after reflection is reflected back along the same direction, or if the ray of light passes through center of curvature after reflection, it moves in the same direction only. That means, it passes through the center of curvature only. And even in case of a convex mirror, a ray of light directed towards the center of curvature after reflection, it is reflected back along the same direction. In case of both concave and convex mirror, if the ray of light directed obliquely and at the pole, and it is reflected obliquely making equal angle with the principal axis. That means, if the ray of light incident at the pole of the mirror after reflection, it is reflected and which makes the equal angle with the incident angle. That means, in this case the ray of light obeys first law of reflection, that is, angle of incidence is equal to angle of reflection. Now, come to the our today's important topic, image is formed by concave mirror and the ray diagram with respect to the concave mirror. When we are going to conduct the experiment with the help of a concave mirror and a screen and a long scale which is placed on the table, if you are going to place the object at different distances like this, what you are seeing in the animation, we are going to get the image at different distances from the concave mirror, and there is a variation in the size as well as the position. And if you are going to draw the ray diagram geometrically, we are going to get the same result and what we have got from the experimental results. Now, what happens when the object is placed at infinity? Infinity means a little far distance from the concave mirror like this. If the ray of light passes parallelly with the principal axis, then they are going to reflect from the concave mirror and the reflected ray focus at the principal focus. Here, this method is used to find out the focal length of the concave mirror. So, what is the nature and position and relative size of the image? It is very easy to remember. You have to note this point. Image position is at the principal focus and the relative size is highly diminished, and nature of the images, it is real and inverted. So, just watch the animation again. If the object is placed at infinity, then reflected rays are going to meet at principal focus. You have to remember the nature, relative size and the position of the image also. Now, what happens if we place beyond C? Here beyond C means beyond center of curvature. If you are going to place object beyond C like this, you know that the rays moves parallel with the principal axis. After reflection, the ray which is passes through the principal focus, then another ray which is passes through the center of curvature. They are going to meet here, that is in between C and F. Then if you are going to compare the height of the object and height of the image, you will come to know the nature of the image is formed. When it is placed beyond C, here we are noticing inverted image and the size is very small and the position of the image is between C and F. Here I am showing you again nature and position and relative size of the image. When the object is placed beyond C, the image position is between F and C, the relative size is diminished and the nature of the image is in this case also real and inverted. I am showing you again. This is how the image is going to be formed when the object is placed beyond C. Now, what happens if we place at center of curvature, that is at C? See, the ray here also passes parallel with the principal axis and after reflection it is passes through principal focus and one more ray you are seeing there. See, now observe where the image is formed. Image is also formed at C. Then compare the height of the image or size of the image. Here the both object size as well as image size is same and here also we have got inverted image. Here image position where the image is formed at C. Then what about the relative size? It is as same as the object size. And what is the nature of the image? It is simple, it is real and inverted. Now, what happens if we place between C and F? See, if we place like this, then see the ray of light which is going to be reflected from the concave mirror. So, this is how reflection is going to be takes place and image is formed over here. Where is the position of the image? It is beyond C. When the object is between C and F, the image is formed beyond C. Then compare the size of the object as well as the image. Here the size of the image is more than that of the object size. So, here also there is an inverted image and we can notice the three important things. The position of the image is beyond C, then nature is inverted, then size is enlarged. See, image position is beyond C, relative size is enlarged and nature is real and inverted. It is very important for the point of examination also. You have to practice this ray diagrams along with the nature of the image formed by the concave mirror. Now, what happens if we place the object at F? When we place the object at F, then this is how reflected rays are comes out from the concave mirror and here in this case the image position is at infinity, then relative size is highly enlarged, then nature is here also real and inverted. So, when we place the object at infinity, you know that the image position is at principal focus. When we place the object is at principal focus, then image is formed at infinity. Here you have to notice this highly enlarged image is going to be formed. Now, what happens if we place the object between F and P? What happens here in this case? Here in this case, image is formed beyond the mirror. Now, compare the position as well as height. Position is beyond the mirror, then nature is enlarged and erect image, but in this case a virtual image is going to be formed. See, image position is behind the mirror, relative size is enlarged and nature is virtual and erect. You have to notice this point. Only in this case you are getting virtual image, but all in the previous cases you have got a real image. So, this is only the important key point you have to notice in case of the image formed by the concave mirror when the object is placed between P and F. Now, my dear student, so we have learnt about all these things. Just try to recall the position of the image, image size as well as the nature of the image when the object is placed at different distances. Then what happens when the object is placed at infinity? Can you recall? Yes, you can recall easily. The image position is at f. What about image size? It is highly diminished. And what is the nature of the image? It is real and inverted. Can you recall all these three important things when the object is placed beyond C? Yes, you can recall easily. The position of the image is between C and F, then image size is diminished and nature of the image is real and inverted. Then what happened when the object is placed at C? Yes, the image position also is at C. Then what is the size? It is as same as the object size. Then what is the nature of the image? Here also real and inverted image is going to be formed. Then what happens when we place between C and F? Image is formed beyond C, then size of the image is enlarged and nature of the image is real and inverted. What about when the object is placed at F? Can you recall? Yes, and you are capable to say the answer for this question. It is definitely the image position is at infinity, image size is highly enlarged and nature of the image is real and inverted. What happens if it is placed between P and F? You know that the image formed beyond the mirror and image size is enlarged and nature of the image is virtual and direct. My dear student, now come to the uses of concave mirrors. Based on the nature of the image formed by the concave mirror, we are going to utilize those principles or the nature of the image formed by the concave mirror in the construction of different devices which we are going to use in our daily life. The very first use of concave mirror is the concave mirrors are used in torch. Front portion of the torch consists of concave mirror. So, which gives us a narrow and a parallel beam of ray of lights. Concave mirrors are used in searchlight. These concave mirrors are also used as shaving mirrors, because which gives an enlarged image when you are going to place our face nearer to it. Then it is also used by the dentist to see the larger image of the teeth. So, if there is a dental decay and if there is any fault in the enamel, tooth enamel and all, we can notice them easily, because when the teeth is going to be placed between P and F, we are going to get the enlarged image and we can notice the faults of the teeth easily and we can give the medicines accordingly. Then large concave mirrors are used in solar furnaces to concentrate the sunlight. You know that when the sunlight is going to be concentrated at a particular point, the object is going to be heated up and it produces more heat. So, that is why large concave mirrors are used in solar furnaces to heat the water. Then concave mirrors are also used as vehicles headlights. Again I told you already, to get the narrow beam of light and which is having high density light. We have another type of mirror, that is convex mirror. Let us learn the nature of the image formed by the convex mirror when the object is placed at different distances from the convex mirror. Here we are going to place the object in two different places. One is at the infinity. When the object is placed at infinity, highly diminished and virtual and erect image is going to be formed. So, in case of convex mirror, you have to notice that virtual image is going to be formed, erect image is going to be formed and diminished image is going to be formed, and there is no enlarged image in this case. A convex mirror do not produces enlarged image. When the object is placed between infinity and the pole, there is a infinity over somewhere else and there is a pole. When the object is going to be placed between P and infinity, then we are going to get the image over here like this, and in this case also diminished image, erect and virtual image is going to be formed. These are the two important things you have to notice in case of convex mirror. Where we are going to use this convex mirror? It is well known to you, it is used in vehicles as a rear view mirror. My dear student, what is the reason for using convex mirrors as a rear view mirror? Convex mirrors are preferred because they always gives an erect though diminished image. Also, they have a wider field view as they are curved outward. Thus, convex mirrors enable the driver to view much more the larger area than would be possible with a plane mirror. So, when compared to convex mirror as well as plane mirror, these convex mirror produces or covers larger field when compared to plane mirror. So, that is why convex mirrors are used as rear view mirrors. See here, almost all the maximum area which is going to be covered by the convex mirror, it is very easy to driver to see the vehicles which is coming behind him like this. My dear student, we are going to use the mirror formula to calculate the focal length, image distance and object distance which is given in the numericals. And also we have a magnification formula which is going to be calculated with the help of the relationship between height of the image as well as the height of the object. Here the mirror formula, the letters which is used in mirror formula, that is 1 over f is equal to 1 over v plus 1 over u. F indicates focal length, v indicates image distance, u indicate object distance. Magnification is going to be calculated with the help of height of the image as well as the height of the object. The ratio of these two gives us magnification. Magnification is also calculated by using the formula minus v by u. Here v indicates image distance and u indicate object distance. Note this point, my dear student. A negative sign in the value of the magnification indicates that the image formed is a real image, and if a positive sign is obtained in the value of the magnification indicates that image is virtual. If you are going to get negative sign in the calculation, it indicates that image formed is a real image. If it is going to be positive, the image formed is a virtual image. My dear student, you have learned few important concepts of this lesson today, and it is the time to recapitulate all those things. Now we are having a quiz. I will ask few questions and I will give you 4 options, and recall the things what you have learned today and answer my questions. Now come to the first question. The first question is the position where image formed when object is placed at infinity in front of the concave mirror. You have 4 options. You have 4 options. The first option A is at C, B option is between F and C, C option is beyond C, and D option is at F. You have to choose one among all these 4 options. Have you got the answer? Test your answer. Yes, it is at F. When the image object is placed at infinity, the image formed in case of concave mirror at F. Now, let us come to the second question. The position where the object should be placed in front of a concave mirror to get an image, it is as same as the object size. You have 4 options: A between F and C, B at C, C beyond C, D at F. What is your answer? Your answer is correct. The answer is B, that is at C. Now, come to the next question. Position in which the object should be placed in front of the concave mirror in order to obtain virtual and erect image. Where we have to place to get virtual and direct image? Just remember the important points I had given year before, and you have 4 options: Option A is at P, B between P and F, C at F, D at C. What is your answer? Yes, you have chosen correctly. The answer is between P and F. The next question is, the convex mirror is used as a rear view mirror because you have to find the reason among 4 options. The 4 options for this question are: it gives more field view, B produce enlarged image, C produce inverted image, D produce real image. Which is the correct answer among the 4 options? It is A. Your answer is correct. It gives more field view, that is why it is used as a rear view mirror. And the next question is, the focal length of the concave mirror whose radius of curvature is 30 centimeter is. What is the answer for this question? If the radius of curvature is 30 centimeter, what about its focal length? Just remember the relationship between radius of curvature and focal length, you will get the answer for this question. The answer for this question is P, that is 15 centimeter. My dear student, you have a questions for home assignment. So, just recall what you have learned today and write the answer for these questions. The first question is, look at the picture and answer the following questions. A. What is the type of mirror that produced image of the doll's face? The next question is, what is the reason for the formation of a large image or enlarged image of the doll's face? There is another question. Write the medical applications of this type of mirror. You have to answer these 3 questions just by recalling the concept we have learned today. And my next question is, can we use concave mirror as a rear view mirror? Justify your answer with the appropriate reason. Convex mirrors cannot be used in solar furnace, give reason. And the fourth question is, draw the ray diagram to show the formation of image by convex lens when the object is placed beyond 2f. You have to draw a ray diagram for the fourth question, my dear student. And I thank you very much for all of you for your good participation and for watching this program, and I wish you all the best. Thank you so much.